A watch is a small timepiece intended to be carried or worn by a person. It is designed to keep working despite the motions caused by the person's activities. A wristwatch is designed to be worn on a wrist, attached by a watch strap or other type of bracelet. A pocket watch is designed for a person to carry in a pocket. Watches evolved in the 17th century from spring-powered clocks, which appeared as early as the 14th century. The first watches were strictly mechanical, driven by clockwork. As technology progressed, mechanical devices, used to control the speed of the watch, were largely superseded by vibrating quartz crystals that produce accurately timed electronic pulses. Some watches use radio clock technology to regularly correct the time. The first digital electronic watch was developed in 1970. Most inexpensive and medium-priced watches, used mainly for timekeeping, are electronic watches with quartz movements. Expensive collectible watches, valued more for their elaborate craftsmanship, aesthetic appeal and glamorous design than for simple timekeeping, often have purely mechanical movements and are powered by springs. Even though these movements are generally less accurate and more expensive than electronic ones, various extra features, called complications, such as moon phase displays and the different types of tourbillon, are sometimes included. Modern watches often display the day, date, month and year, and electronic watches may have many other functions. Time-related features such as timers, chronographs and alarm functions are common. Some modern designs incorporate calculators, GPS and Bluetooth technology or have heart rate monitoring capabilities. Watches incorporating GPS receivers use them not only to determine the position, they also receive and use time signals from the satellites, which make them essentially perfectly accurate timekeepers, even over long periods of time. Recent developments include smartwatches, which are elaborate computer-like electronic devices designed to be worn on a wrist. They generally incorporate timekeeping functions, but these are only small fractions of what the watch can do. The study of timekeeping is known as horology. History. Watches evolved from portable spring-driven clocks, which first appeared in 15th century Europe. Watches weren't widely worn in pockets until the 17th century. One account says that the word watch came from the Old English word woake, which meant watchman, because it was used by town watchmen to keep track of their shifts at work. Another says that the term came from 17th century sailors, who used the new mechanisms to time the length of their shipboard watches. A great leap forward in accuracy occurred in 1657 with the addition of the balance spring to the balance wheel, an invention disputed both at the time and ever since between Robert Hooke and Christian Huygens. This innovation increased watches' accuracy enormously, reducing error from perhaps several hours per day to perhaps 10 minutes per day, resulting in the addition of the minute hand to the face from around 1680 in Britain and 1700 in France. The increased accuracy of the balance wheel focused attention on errors caused by other parts of the movement, igniting a two-century wave of watchmaking innovation. The first thing to be improved was the escapement. The verge escapement was replaced in quality watches by the cylinder escapement, invented by Thomas Tompion in 1695 and further developed by George Graham in the 1720s. Improvements in manufacturing such as the tooth-cutting machine devised by Robert Hooke allowed some increase in the volume of watch production, although finishing and assembling was still done by hand until well into the 19th century. A major cause of error in balance wheel timepieces, caused by changes in elasticity of the balance spring from temperature changes, was solved by the bimetallic temperature-compensated balance wheel invented in 1765 by Pierre Leroy and improved by Thomas Earnshaw. The lever escapement was the single most important technological breakthrough, and was invented by Thomas Mudge in 1759 and improved by Josiah Emery in 1785, although it only gradually came into use from about 1800 onwards, chiefly in Britain. The British had predominated in watch manufacture for much of the 17th and 18th centuries, but maintained a system of production that was geared towards high-quality products for the elite. Although there was an attempt to modernize clock manufacture with mass production techniques and the application of duplicating tools and machinery by the British Watch Company in 1843, it was in the United States that this system took off. Aaron Lufkin Dennison started a factory in 1851 in Massachusetts that used interchangeable parts, and by 1861 it was running a successful enterprise incorporated as the Waltham Watch Company. Wristwatch. The concept of the wristwatch goes back to the production of the very earliest watches in the 16th century. Elizabeth I of England received a wristwatch from Robert Dudley in 1571, described as an arm watch. From the beginning, wristwatches were almost exclusively worn by women, while men used pocket watches up until the early 20th century. Wristwatches were first worn by military men towards the end of the 19th century, when the importance of synchronizing maneuvers during war, without potentially revealing the plan to the enemy through signaling, was increasingly recognized. The Garston Company of London patented a watch wristlet design in 1893, but they were probably producing similar designs from the 1880s. Officers in the British Army began using wristwatches during colonial military campaigns in the 1880s, such as during the Anglo-Burma War of 1885. During the Boer War, the importance of coordinating troop movements and synchronizing attacks against the highly mobile Boer insurgents became paramount, and the use of wristwatches subsequently became widespread among the officer class. The company Mappin and Webb began production of their successful campaign watch for soldiers during the campaign at the Sudan in 1898 and ramped up production for the Boer War a few years later. These early models were essentially standard pocket watches fitted to a leather strap, but by the early 20th century, manufacturers began producing purpose-built wristwatches. The Swiss company, Daimler Frère & Cie, patented a wristwatch design with the now standard wire lugs in 1903. Hans Wilsdorf moved to London in 1905 and set up his own business with his brother-in-law Alfred Davis, Wilsdorf & Davis, providing quality timepieces at affordable prices. The company later became Rolex. Wilsdorf was an early convert to the wristwatch, and contracted the Swiss firm Egler to produce a line of wristwatches. The impact of the First World War dramatically shifted public perceptions on the propriety of the man's wristwatch, and opened up a mass market in the post-war era. The creeping barrage artillery tactic, developed during the war, required precise synchronization between the artillery gunners and the infantry advancing behind the barrage. Service watches produced during the war were specially designed for the rigors of trench warfare, with luminous dials and unbreakable glass. The British War Department began issuing wristwatches to combatants from 1917. By the end of the war, almost all enlisted men wore a wristwatch, and after they were demobilized, the fashion soon caught on. The British Horological Journal wrote in 1917 that the wristlet watch was little used by the sterner sex before the war, but now is seen on the wrist of nearly every man in uniform and of many men in civilian attire. By 1930, the ratio of wrist to pocket watches was 50-1. The first successful self-winding system was invented by John Harwood in 1923. The introduction of the quartz watch in 1969 was a revolutionary improvement in watch technology. In place of a balance wheel which oscillated at 5 beats per second, it used a quartz crystal resonator which vibrated at 8,192 Hz, driven by a battery-powered oscillator circuit. Since the 1980s, more quartz watches than mechanical ones have been marketed. Movement. A movement of a watch is the mechanism that measures the passage of time and displays the current time. Movements may be entirely mechanical, entirely electronic, or they might be a blend of both. Most watches intended mainly for timekeeping today have electronic movements, with mechanical hands on the watch face indicating the time. Mechanical movements compared to electronic movements. Mechanical watches are less accurate, often with errors of seconds per day, and they are sensitive to position, temperature and magnetism. They are also costly to produce, require regular maintenance and adjustments, and are more prone to failures. Nevertheless, the craftsmanship of mechanical watches still attracts interest from part of the watch-buying public, especially among the watch collectors. Skeleton watches are designed to leave the mechanism visible for aesthetic purposes. A mechanical movement uses an escapement mechanism to control and limit the unwinding and winding parts of a spring, converting what would otherwise be a simple unwinding into a controlled and periodic energy release. A mechanical movement also uses a balance wheel together with the balance spring to control motion of the gear system of the watch in a manner analogous to the pendulum of a pendulum clock. The tourbillon, an optional part for mechanical movements, is a rotating frame for the escapement, which is used to cancel out or reduce the effects of gravitational bias to the timekeeping. Due to the complexity of designing a tourbillon, they are very expensive, and only found in prestigious watches. The pin lever escapement, which is a cheaper version of the fully levered movement, was manufactured in huge quantities by many Swiss manufacturers as well as by Timex, until it was replaced by quartz movements. Tuning fork watches use a type of electromechanical movement. Introduced by Bulova in 1960, they use a tuning fork with a precise frequency to drive a mechanical watch. The task of converting electronically pulsed fork vibration into rotary movements is done via two tiny jeweled fingers, called pawls. Tuning fork watches were rendered obsolete when electronic quartz watches were developed. Quartz watches were cheaper to produce besides being more accurate. Traditional mechanical watch movements use a spiral spring called a mainspring as a power source. In manual watches, the spring must be rewound periodically by the user by turning the watch crown. Antique pocket watches were wound by inserting a separate key into a hole in the back of the watch and turning it. Most modern watches are designed to run 40 hours on a winding and thus must be wound daily. But some run for several days and a few have 192-hour mainsprings and are wound weekly. Automatic watch is a self-winding or automatic watch is one that rewinds the mainspring of a mechanical movement by the natural motions of the wearer's body. The first self-winding mechanism was invented for pocket watches in 1770 by Abraham Louis Perellet, but the first self-winding, or automatic, wristwatch was the invention of a British watch repairer named John Harwood in 1923. This type of watch winds itself without requiring any special action by the wearer. It uses an eccentric weight, called a winding rotor, which rotates with the movement of the wearer's wrist. The back and forth motion of the winding rotor couples to a ratchet to wind the mainspring automatically. Self-winding watches usually can also be wound manually to keep them running when not worn or if the wearer's wrist motions are inadequate to keep the watch wound. In April 2014, the Swatch Group launched the System 51 wristwatch. It has a purely mechanical movement consisting of only 51 parts, including a novel self-winding mechanism with a transparent oscillating weight. So far, it is the only mechanical movement manufactured entirely on a fully automated assembly line. The low parts count and the automated assembly make it an inexpensive mechanical Swiss watch, which can be considered a successor to Roscoff movements, although of higher quality. Electronic movements, also known as quartz movements, have few or no moving parts, except a quartz crystal which is made to vibrate by the piezoelectric effect. A varying electric voltage is applied to the crystal, which responds by changing its shape so, in combination with some electronic components, it functions as an oscillator. It resonates at a specific highly stable frequency, which is used to accurately pace a timekeeping mechanism. Most quartz movements are primarily electronic but are geared to drive mechanical hands on the face of the watch to provide a traditional analog display of the time, a feature most consumers still prefer. In 1959, Seiko placed an order with Epson to start developing a quartz wristwatch. The project was codenamed 59A. By the 1964 Tokyo Summer Olympics, Seiko had a working prototype of a portable quartz watch which was used as the time measurements throughout the event. The first prototypes of an electronic quartz wristwatch were made by the Che Research Laboratory in Neuchâtel, Switzerland. From 1965 through 1967, pioneering development work was done on a miniaturized 8192 Hz quartz oscillator, a thermocompensation module and an in-house made, dedicated integrated circuit. As a result, the Beta 1 prototype set new timekeeping performance records at the International Chronometric Competition held at the Observatory of Neuchâtel in 1967. In 1970, 18 manufacturers exhibited production versions of the Beta 21 wristwatch, including the Omega Electro Quartz as well as Patek Philippe, Rolex Oyster Quartz and Piaget. The first quartz watch to enter production was the Seiko 35 Square Astron, which hit the shelves on 25 December 1969, swiftly followed by the Swiss Beta 21, and then a year later the prototype of one of the world's most accurate wristwatches to date, the Omega Marine Chronometer. Thanks to the technology having been developed by the Swiss, Seiko could not patent the whole movement of the quartz wristwatch, thus allowing other manufacturers to participate in the rapid growth and development of the quartz watch market. This ended, in less than a decade, almost 100 years of dominance by the mechanical wristwatch legacy. Modern quartz movements are produced in very large quantities, and even the cheapest wristwatches typically have quartz movements, whereas mechanical movements can typically be off by several seconds a day. An inexpensive quartz movement in a child's wristwatch may still be accurate to within half a second per day, 10 times more accurate than a mechanical movement. After a consolidation of the mechanical watch industry in Switzerland during the 1970s, mass production of quartz wristwatches took off under the leadership of the Swatch Group of companies, a Swiss conglomerate with vertical control of the production of Swiss watches and related products. For quartz wristwatches, subsidiaries of Swatch manufacture watch batteries, oscillators and integrated circuits. The launch of the new Swatch brand in 1983 was marked by bold new styling, design and marketing. Today, the Swatch Group maintains its position as the world's largest watch company. Seiko's efforts to combine the quartz and mechanical movements bore fruit after 20 years of research, leading to the introduction of the Seiko Spring Drive, first in a limited domestic market production in 1999 and to the world in September 2005. The Spring Drive keeps time within quartz standards without the use of a battery, using a traditional mechanical gear train powered by a spring, without the need for a balance wheel either. Radio time signal watches are a type of electronic quartz watch which synchronizes its time with an external time source such as in atomic clocks. Time signals from GPS navigation satellites, the German DCF-77 signal in Europe, WWVB in the US, and others. Movements of this type may, among others, synchronize the time of day and the date, the leap year status, and the state of daylight saving time. However, other than the radio receiver, these watches are normal quartz watches in all other aspects. Electronic watches require electricity as a power source, and some mechanical movements and hybrid electronic mechanical movements also require electricity. Usually the electricity is provided by a replaceable battery. The first use of electrical power in watches was as a substitute for the mainspring, to remove the need for winding. The first electrically powered watch, the Hamilton Electric 500, was released in 1957 by the Hamilton Watch Company of Lancaster, Pennsylvania. Watch batteries are specially designed for their purpose. They are very small and provide tiny amounts of power continuously for very long periods. In most cases, replacing the battery requires a trip to a watch repair shop or watch dealer. This is especially true for watches that are water-resistant, as special tools and procedures are required for the watch to remain water-resistant after battery replacement. Silver oxide and lithium batteries are popular today. Mercury batteries, formerly quite common, are no longer used, for environmental reasons. Cheap batteries may be alkaline, of the same size as silver oxide cells but providing shorter life. Rechargeable batteries are used in some solar-powered watches. Some electronic watches are powered by the movement of the wearer. For instance, Seiko's kinetic-powered quartz watches use the motion of the wearer's arm, turning a rotating weight which causes a tiny generator to supply power to charge a rechargeable battery that runs the watch. The concept is similar to that of self-winding spring movements, except that electrical power is generated instead of mechanical spring tension. Solar-powered watches are powered by light. A photovoltaic cell on the face of the watch converts light to electricity, which is used to charge a rechargeable battery or capacitor. The movement of the watch draws its power from the rechargeable battery or capacitor. As long as the watch is regularly exposed to fairly strong light, it never needs battery replacement. Some models need only a few minutes of sunlight to provide weeks of energy. Some of the early solar watches of the 1970s had innovative and unique designs to accommodate the array of solar cells needed to power them. As the decades progressed and the efficiency of the solar cells increased while the power requirements of the movement and display decreased, solar watches began to be designed to look like other conventional watches. A rarely used power source is the temperature difference between the wearer's arm and the surrounding environment.